providers. We've asked them to keep their remarks as short as possible, aiming for no more than like 5 to 7 minutes or something per person. And then after we finish, we will go into some questions. I have a few questions to start us off, but we will be also looking to the audience for any additional questions. So as we go through, please think of your questions and hold those until we get to the question session, and then we'll open it up for people who would like to ask questions for our providers. So we will go ahead and get started. Our first, I'm not going to do a full introduction. I'll just mention who the presenter is, what country they're representing, and what organization or office. So we will get started with GPS, Dr. Chris Erickson, representing the United States Space Force.
Good afternoon. Oh, thank you. I'm Chris Erickson. I work for the U.S. Department of Defense in the United States Space Force Service. We own and operate the GPS constellation and are also responsible for its sustainment and improvement. Currently, the GPS constellation has 38 satellites. Oh. That was, yeah, I'm not, okay. I'm not gonna, yeah, I'm okay. So currently we have 38 satellites in orbit. 31 are part of the active constellation. Most of those are part of our GPS-2 space vehicles. There's a couple of variants there. And we have recently been launching GPS-3 vehicles. There are now 6 GPS-3 vehicles on orbit. The next one will be launched, we expect, this June. And there are 3 more beyond that one that are also already built and in storage. We expect to launch them in 25 and also in 2026. Following those GPS-3 vehicles, now next slide please, we will begin launching our, oh, there we go. We'll begin launching our GPS-3F. The GPS-3F stands for GPS follow-on. These vehicles include some additional upgrades from the previous ones. One of them is a system called Regional Military Protection. That is a boosted signal to provide resilience against jamming environments. It will also have an upgraded nuclear detection system and search and rescue payload for faster detection and location of distress signals. The GPS-3F vehicles will also include laser retroreflectors, which will help improve precise ranging data. And they are also meant to be an on-ramp to new technologies that are under investigation at the Air Force Research Laboratory. I don't actually have any information on new technologies that might on-road onto the GPS-3F vehicles at this time, but we keep that open as a possibility going into the future. As part of that, Air Force Research Laboratory is launching a satellite called the Navigation Technology Satellite 3, and I'll talk about that a little later on. Also, as part of our upgrades to the system, we are going to be installing a new operational control system called OCX. This will improve our cyber resiliency, enhanced command and control of our constellation, and it will also be able to bring online several new civilian signals that will be very important. Oh. Yeah, there we go. Okay. Oh, I can just ask. So the new civil signals are L2C, which allows multi-frequency users to get ionospheric correction between that and L1CA. It also, excuse me, There will also be a L1C signal, which will improve interoperability between the GPS constellation and other global navigation satellite service providers. Both QZSS and Beidou are also onboarding L1C-like signals to help with that. And then farther in the future will be an L5 signal, which is specific for safety of life. It's compatible with the aviation industry, and it's protected by the International Telecommunications Union for aviation uses. Next, please. So as we go into the future, this year we expect to launch the Navigation Technology Satellite 3. This is a test bed for potential technologies that we would like to potentially use in the future for GPS. It includes reprogrammable signals. It includes testing of some atomic clock technologies for improved timing, and also demonstrates geosynchronous augmentation of GPS. Next slide, please. And then in the very far future, well, in the slightly farther future perhaps, we envision the use of user equipment that uses not just GPS, but all of the navigation satellite signals available. As you know, user equipment is perhaps the largest challenge in using GNSS, and it will take a little bit of time, but we foresee this as kind of the future, using signals that are available to everybody from all of the constellations. As a step towards that, we have been developing GPS user equipment that will initially include Galileo and QZSS, and we expect to be able to develop that further by working with equipment manufacturers in the future. All right, next slide. Thank you very much.
Okay, thank you very much, Dr. Erickson. So our next presenter will be done virtually for representing the Galileo program, Mr. Dominic Hayes from the European Commission, Director General for the Defense Enterprise. I don't remember the full acronym, Dominic. I'll let you take it from there and talk about your current title and the Galileo program. So over to you.
Morning, Jeff, and good morning, everyone. Yes, it's the Directorate General for Defense Industry and Space. So we manage the EU satellite navigation programs Galileo and EGNOS, as well as the other EU space programs Copernicus and the new IRIS² satellite communications constellation. So thank you, Jeff and Chris. Chris, you've set the bar in terms of very short presentation. I'm sorry, I probably won't achieve that level of brevity, but here I go. Before I start, I just would like to remind the meeting, as is my duty as a European Commission official, to remind the meeting of to take a moment to remember the innocent victims of the unprovoked Russian war of aggression against Ukraine. The EU remains fully in support of Ukraine and its objectives to reclaim the internationally recognized borders that define the country of Ukraine. Thank you. So, Galileo program. Are you showing my slides, or am I showing my slides?
Yeah, we have your slides up.
Okay.
I think just
so
say
first
next slide when you're ready.
Next slide, please. Yeah, thanks. So this first slide is to really emphasize the performance that we've achieved for Galileo since we've been running. We now have a service that's providing ranging errors down to the around 20-25 centimeter level, which is currently the best performance that you can achieve from any satellite navigation system. Next slide, please. So this year we've been strengthening the ground infrastructure. The ground infrastructure is often the forgotten part of any satellite navigation system, but it's really essential to achieve the performance that we get from from our systems, whether that be GPS, whether it be Galileo, whether it be GLONASS, whether it be Beidou, they all require a very solid ground infrastructure to achieve performance. So this year we've been working on building up that ground infrastructure. Next slide, please. So we have some, back one slide, please. So we have some improvements. The INAV signal, so this is residual message capacity that we had after we restructured the Galileo signal a few years ago. This includes some new resiliency for the data acquisition and some synchronization patterns to improve the time to first fix. That signal is now being tested on the GSAT 201 and 202, which were the first of the, excuse me, first of the satellites we launched from our new batch back in 2016, I think it was. So this will enable faster acquisition of the Galileo signal, and that will improve performance for users. We're also in the future planning to introduce a new pilot signal on E5. This will enable faster acquisition of the E5 signal, potentially in single frequency mode, so it will no longer need to have the E1 signal received first before picking up E5. So that's an interesting new feature that is coming in the next few years. Next slide, please. So we've also got the high accuracy service, and this is a service that's also provided free of charge. It uses the E6 signal, and this will provide an accuracy of around 20 centimeter level. It's almost a global service. It was launched last year. It has at the moment the focus is on providing the performance in Europe, so you can achieve 20 centimeters in Europe with a convergence time of around 100 seconds, I think it is. In other parts of the world, that convergence time is around 300 seconds. But eventually, as we roll out more ground stations with uplink capability, that will decrease the convergence time and offer 20 centimeter level globally in a very fast acquisition time frame. Next slide, please. Another new feature coming is the emergency warning satellite service using a message structure we've been developing with colleagues from JAXA. This is to provide emergency warning messages through the navigation signal in times of crisis. Authorized entities within a country can request the Galileo system to transmit an emergency warning message that can be received by GNSS receivers on things like smartphones, for example. Where terrestrial infrastructure is knocked out by, say, forest fires or maybe tsunamis or earthquakes, the satellite signal will still be able to be received. Next slide, please. And search and rescue. So this is something that we've had in our system for a number of years. It's been a huge success in terms of the number of lives that it's been able to save. We have some new features added to the search and rescue service. These are coming soon or in the next few years. So we have the remote beacon activation. This is a standard that's now been approved by EUROCAE, which is an aviation standards making body in Europe. And also two-way communications. This will enable communications between beacons, emergency beacons in the same vicinity, and this will help rescues. These are features that are planned to be introduced in the 2025 timeframe, where we have a pilot service which will be launched in that year. And then another feature that's a bit longer on the horizon. This is distress beacon position sharing. This is to enable beacons within the same area to be notified when a rescue is underway and share the position of the beacon that is in distress. This will enable faster or potentially faster rescues of people in distress. We have a new MeAlert station that's now based on the Reunion Island. and that will give improved performance in the Indian Ocean area. So it also covers partly the Thailand area, actually. So that will improve performance for search and rescue locations from beacons in your area. Next slide, please. Okay, spoofing. It's becoming a challenge for many of the GNSS operators around the world. And OS NMA is our attempt at trying to minimize the disruption that can be caused by spoofing. We've seen spoofing occurring in some parts of the world now, and it's becoming technically easier for malicious parties to disrupt GNSS reception. So this is not just jamming, but actually trying to mislead a GNSS receiver. So Galileo has this open service navigation message authentication, which we are adding to our open service, and this will enable the Galileo message to be authenticated, which gives some additional confidence that the position you are receiving is from Galileo and not from a malicious spoofer. So we're planning to declare initial service of OS NMA in early 2024, and we know that the first OS NMA receivers are now on the market. So look out for this new feature, which we think will be a very important one for all GNSS users. Next slide, please. So we mustn't stop still. We are already looking to the next generation of Galileo, so what we call the second generation, G2G, which will use new features and provide additional performance to our Galileo users. And then looking even further beyond, we're also investigating things like quantum technologies, enhanced clocks on the satellites to provide even more performance. And just to highlight the release of this new Earth observation and GNSS market report, which is a report that's released every 2 years by our agency, EU agency for the space program. This is a very interesting report. It's available from the USPA website there. The link is there. I recommend that you download this. It contains a lot of useful information, and much of what we do is driven by the market. And this document does detail the current GNSS market and predictions for the future. So it's a very useful document to many organizations around the world. And with that, I will conclude my presentation. Thank you.
Okay, great. Thank you very much, Dominic. So we will move on, and the next presenter is representing the Beidou program, and it's Dr. Cheng Fong from the National Time Service Center.
Good afternoon, ladies and gentlemen. I'm Chen Fang from National Time Service Center, Chinese Academy of Sciences. I'm very glad to be attending this Multi-GNSS Asia Annual Conference. Now, I'm going to present the latest development of Beidou navigation satellite system. Okay. On December 26 last year, the 5th, 7th, and the 5th, 8th satellites for BDS were launched at Xichang, which upgrade functions and the performance in various areas, improve the reliability and the service capability, including global short message communication capacity, onboard atomic clock technology, and the intelligent payloads. Now we have a total of 48 satellites operational in orbit, including 50 BDS-2 satellites and 33 BDS-3 satellites. About the high accuracy applications and -2 high -2 applications, one is for terrain monitoring. Confronted with the threat of potentially natural disaster in Saris Lake in Tajikistan, China and Tajikistan utilized the BDS to undertake the deformation monitoring and disaster warning in surrounding area in millimeter level accuracy, providing important scientific and technological reference for the safety of the dam. In October last year, China-Tajikistan cooperation on the dam proudly listed one of the 10 typical cases of the Third Belt and Road Forum for international cooperation. Another one is precision agriculture. Based on BDS real-time high-precision positioning technique, the positioning solution of intelligent agricultural machinery for conservation, intelligent automation, and precision operation is realized in protector of black soil in China, which will be adaptive for different kinds of agricultural machinery, such as rice transplanter, reaping, and plant protection, and be available for different application scenarios. In 2023, based on China-Russian Satellite Navigation Key Strategic Cooperation Project Committee mechanism, the first China-Russian Space Cooperation Subcommittee was successfully held. The second subcommittee is to be held in the third quarter in China. This is one of the most important achievements for BDS bilateral cooperation. For the ratification by international standards, in November last year, BDS technical standards and recommended measures has been added to the ECO's existing standard documents in Annex 10 of the Convention on International Civil Aviation. Regulated by ECO, BDS becomes global used navigation satellite system. In the future, 2 backup satellites are scheduled to be launched to strengthen the robustness and the accessibility of the BDS constellation. For the fusion with other technologies, research on improving navigation with low Earth orbit technologies, as well as its practical applications, will be further promoted to strengthen the precision and the integrity of the system. Meanwhile, the integration of BDS with innovative realms such as 5G, artificial intelligence, and big data will be accelerated steadfastly, aiming to shape a national PNT system that's more ubiquitous, integrated, and intelligent by 2035. This is the end of my presentation. Thank you so much for your concern and support to BDS. Thank you.
Okay, thank you very much, Dr. Chung. So our next speaker is representing the GLONASS program, Mr. Ivan Revnevik from Roscosmos. Ivan, over to you. And Ivan will be presenting remotely. Yes.
Thank you very much, Jeff. Yes, Ivan Revnevik speaking. As a representative for Roscosmos State-Based Corporation, and I'm a GLONASS head of the GLONASS application and use division. So first of all, my duty also for the European Commission representative to say that everything that you have declared is absolutely none of your business and has nothing to do with today's conference. Please stop politicizing navigation events. And of course, it's nothing personal, Dominique. So for today, yes, please, next slide. Yeah, the GLONASS constellation currently consists of 26 navigation satellites in medium Earth orbits. As you may see, the full nominal constellation of 24 GLONASS satellites is operational and ensures 100% global coverage and the near 100% availability. The constellation includes 4 GLONASS-K satellites. Besides, the long-awaited first GLONASS K2 satellite was successfully deployed in orbit and now is under flight testing. So next slide, please. Nowadays, GLONASS provided 4 civil services. Any user in any region of the world can access Open GLONASS basic service. It's a position, navigation, and timing service provided with 2 open frequency division signals in L1 and L2 bands. In the future, the service will also be provided with the help of 3 open code division signals in L1, L2, and L3 bands. These signals are already transmitted in pre-operational mode and may be used at the discretion of users. Currently, the half of the constellation already broadcasts the open code division signal in L3 band. Service of improved reliability and accuracy is provided to users in Russia by both System of Differential Correction and Monitoring and ground-based augmentation system designed for user navigation support in accordance with ICAO standards. It will address the operations of System for Differential Correction and Monitoring that will be covered later. Next slide, please. So, as it was mentioned, the first GLONASS-K satellite was successfully launched on August 7, 2023. It already broadcasts new open code division signal in L1 and L2 and as well as L3 open code signal, and already all frequencies division signals also. Another 14 navigation satellites of this batch are planned to be launched, as well as another 6 GLONASS-K satellites that belong to the previous generation. And as you may see, the half of the constellation is capable of broadcasting open signal L3OC. Besides, this slide illustrates the evolution of the GLONASS satellites, and it's focused on gradual implementation of technical system and solution that decrease GLONASS signal and space range and error. It is also important to mention that 5 GLONASS-K satellites will carry Cospas-SARSAT search and rescue equipment receiving signal of distress. Besides, GLONASS-K2 satellite will also carry Cospas-SARSAT search and rescue. Please come back to the slide number 4. Can you hear me?
Yeah, we can hear you. It's a little bit.
Yeah. So,
if you can speak up a little bit, that might be helpful. But we can hear you.
Yeah. So yeah, I'm on the slide. I'm still on slide number 4. Can you turn it back, please? Yes. So it's also important to mention that 5 GLONASS-K satellites will carry Cospas-SARSAT search and rescue equipment receiving signal in distress. Besides, GLONASS-K2 satellite will also carry Cospas-SARSAT search and rescue equipment that also support return link messages in L1LC open signal that will contribute to the international search and rescue. In addition, GLONASS facilitates international laser ranging, as all GLONASS satellites are equipped with laser reflectors also. So for the next slide, please. So the deployment of high-orbit GLONASS space complex will be a new milestone for the improvement of GLONASS performance. The complex will include at least 6 satellites in inclined geosynchronous orbit in 3 orbital planes. The high-orbit GLONASS satellites will broadcast open code division signal in L1, L2, and as well as L3 SVI signal for the correction and integrity of the GLONASS high accuracy service. Speaking of GLONASS basic service, high orbit GLONASS will facilitate increasing positioning accuracy in the Eastern Hemisphere availability in dense urban areas and high latitude Arctic region. Along with that, global adaptive atmospheric model will be transmitted in L1 signal and will somewhat contribute to the compensation of high atmospheric activity in the Arctic region that decreases the position accuracy of single frequency users. The next slide, please. And as I have already mentioned, the GLONASS high accuracy service currently provides users in Russia with the real-time and post-processing precise orbit and clock corrections. So far, through the internet. The accuracy of the service doesn't exceed on average 20 centimeters. The slide shows further plans to develop the service. So there are three major areas of the development. The extension of the information provides to the users, the launch of space-based broadcast channel based on L3 SVI signal broadcasting service, and the implementation of the integrity. Next slide, please. Slide number 7. Yes. So let's proceed to the status of the system of differential correction monitoring. Currently, the system of differential correction monitoring has successfully passed the preliminary certification tests in accordance with the requirements for typical approach operating with the vertical guidance. The system provides real-time corrections for all GLONASS satellites and almost all GPS satellites integrated with the alert time with a 6-second and ionospheric correction for L1 signal that is broadcasted by 2 geo-Luch relay satellites and via the internet. By 2030, DFMS S-bus technology will be implemented, with stipulating the generation of corrections for all the GNSS on dual frequency observations and the transmission of L5 signal. 3 new Luch satellites and 2 geo communication satellites will broadcast L1 and L5 signal. It will ensure at least twofold coverage over the country that is the most extensive in latitude and facilitate finishing 3 certification of the system. The authentication of L1 and L5 signal will also be envisaged. So next slide, please. Slide number 8. Yes, the Roscosmos State Space Corporation is making significant effort to access the GLONASS performance, so verify and confirm the accordance with the guaranteed levels defined in GLONASS Open Service Performance Standard, and ensures that GLONASS domestic and foreign civil users are provided with a basic service for proper quality. Moreover, Roscosmos State Space Corporation is providing both foreign and domestic users with a comprehensive information support through its applied user center based of information and analysis center for position, navigation, and timing, that is chief think tank in satellite navigation in Russia. So thank you very much. I'm done.
Okay, thank you very much, Ivan. So our next presenter will be representing the QZSS program, Mr. Kenji Mikami from Japan Cabinet Office.
Can I use the screen?
Thank you. Thanks to its unique quasi-zenith orbit, it makes figure-8 curves from the Earth ground. And we have now 4 satellites on our head. Now, we are more 3 satellites will be launched in the coming years because we have H3 rocket, domestic rocket, has failed last year. So Japanese development is failed 1 year. So we have next year, we will have the next launches. And new topics as a breaking news to the MDA. We will have a next plan for the expansion. Future plan, 7 to 11 satellite constellations. We will have 4 another satellites for within the 10 or 20 years. So we can get advantage from 7 satellites. We can status of the higher accuracy and the more stable, and backup systems stronger for the resilience and the area expansion. These benefits to the all Southeast Asia. And now QGSS application, it has accuracy of the 6 centimeter class. As of 2023, over 400 products inside it. Autonomous driving, drone system, and other systems. Now, we are seeking receivers with a smaller size and lower prices. It's our struggle with my industries to receive this. And we are now collaboration with various Southeast countries. For example, for Thailand, EWSS, Early Warning System Service, message systems, performed demonstration with DISDA these years. We will do complete these demonstration within years. And as you know, GNSS is now becoming an essential service in our society and the business. And we make it more clear and more compliant. We are the goal. Thank you so much.
Okay, thank you very much, Mr. Mikami. So our next presenter will be a virtual representing the Indian NAVIC program, Dr. Sura from Israel.
Good morning, good afternoon to all of you. My presentation is shared with Jeff. Is it being projected? Yeah, thank you. So myself, P.S. Sudha, as the Program Director for Satellite Navigation Program of Indian Space Research Organization, ISRO India. I'll be giving a brief introduction on the system, NAVIC system and the Gaggan system updates and current status for the system. Next slide. Yeah, as already known, we have the satellite navigation system, NAVIC, navigation with the Indian constellation, it is known. And we have the Gaggan system, which is SBAS system, GPS-aided geo-augmented navigation. In the Gaggan system, we offer standard positioning services as well as restricted services. In SPS services, we have services in L5, L1, and S-band. And restricted service, we have L5 and S-band. And the service area, what we are looking at is regional constellation. It's 1,500 kilometers beyond in India, and its geopolitical boundary around 1,500 kilometers beyond that. And Gaghan point of view, it provides air navigation service, safety of life over the Indian flight information region. And at present, it has been certified for RNP 0.1 and APV1. Next slide. This is our basic architecture. In the space segment for the Navik, it is 7 satellites, 3 GSO satellites and 4 IGSO, inclined GSO satellites. We have got down segment 2 navigation centers and one-way ranging stations. At IRIMS, it is 16 stations, and there are 5 two-way ranging stations. One more is upcoming in Port Blair. And the networking centers, we have got 2 numbers, which are upgraded with in-house timescale feature. And also we have spacecraft control center, 2 numbers. And frequency bands are L5S and L1. And service are SPS and RS. This L1 service is started with the launch of our new satellites, second generation satellites in the series. That is NVS-01 satellite, which is launched in the month of May in 2020-23. So this is the first satellite with L1 service is launched. Next slide. So the follow-on satellite NVS-01 that is launched in last year, which is having an indigenous atomic clock. Also, it is introduced with the L1 frequency band, which is with SBOC modulation and IC4 PRN codes. And it is compatible with and interoperable with other GNSS civilian signals in the L1 band. We are planning to launch another 4 satellites in this series in the upcoming this year as well as followed by next year. Within 2 years, we will be completing this launch of this particular series of satellites. And other important parameters are that NAVIC has been updated, accepted by various global standards like 3GPP, automotive industry standard AS 140, NMEA 0183, and RTCM 10403.3, and the worldwide radio navigation system also accepted as a component, NAVIC as a component. Next slide. Apart from the nominal positioning services, NAVIC is offering short messaging services also for the users in the Indian region through IRNSS 1A and 1E satellites in the first generation series. And this services is being presently used by inquiries for broadcasting potential fishing zone messages and cyclone and high wave alerts, etc., to the fishermen across the country. And also, we are planning to have NAVIC service advisory portal in this year, so that all up-to-date information about the constellation will be available in the advisory. And as other things are, timescale system has been developed and it is operational. It is indigenously developed. And major smartphone manufacturers also in line with including NAVIC signals in their SOCs. And as a part of our new development, NAVIC message authentication service is planned in the future systems. And the testing of this particular NMA is in progress. Already the proof of concept has been demonstrated in one of our satellites. Next slide. This is a few, cooperation with industry, which are the partners with NAVIC. Next slide. Next slide, please. Yeah. About Gaghan, it is a joint development between ISRO and Airport Authority of India. This is to deploy and certify an operational SBAS for India, and to achieve RNP capability of our Indian FIR, and to provide AP1 service, as I mentioned earlier. Next slide. and it's already Gaggan is already certified by DGCA, and we have got 3 satellites at 55 degree, 83 degree, and 93.5 degree, which are operating with different PRN codes of 127, 128, and 132. Next slide. So this is the basic architecture for the Gaggan operating system. Next slide. Thank you. Thank you all.
Okay, thank you very much, Dr. Sura. So our final speaker here in this session will be representing the Korean positioning system, Mr. Jung-min Yu from KARI.
Thank you, Mr. Jeff. Presentation. Good afternoon, everyone. I'm Jung-min Yu from Korea Aerospace Research Institute. Thank you for the opportunity to introduce our KPS and CAS status MJ conference. Okay. The main reason why we are developing KPS is to provide high precision PNT information for emerging technologies such as self-driving car, urban air mobility, or many smart systems which are representative for the fourth industrial revolution. And in addition, we needed a plan to provide the PNT services to meet various satellite navigation needs, such as SBAS, centimeter level service, or search and rescue service. The KPS program was started from 2022, and system development is expected to be completed by 2035. Like other GNSS, the KPS is also composed of 3 segments. The ground segments consist of operation centers, satellite control centers, antenna stations, monitoring stations, and mission control stations. The space segment consists of 3 GEO satellites and 5 inclined geosynchronous orbit satellites. 2 GEO satellites have a SBAS payload, and 1 GEO satellite has a search and rescue payload. Next slide, please. Yeah. Okay. As I mentioned, the KPS program and R&D was started from 2022. We also submitted the application for international satellite network to ITU in 2022 and started coordinating satellite network with other countries from this year. We finished the KPS system design review on June last year. PDR, CDR, and international cooperation will be progressed, and signal and constellation design are also ongoing. In addition, I would like to brief for the status of CAS project. As you may know, the CAS is a Korean satellite-based augmented system. The main goal of CAS is to provide FPV-1 service to the air navigation users on the Incheon FIR area in South Korea. The first CAS geostationary satellite was successfully launched in 2022. We started the AP1 SOS service in December of last year. Okay. As you know, international cooperation is also important for developing KPS system. So we are working with many countries for enhancing comparability and interoperability. In particular, we joined the ICG as a state member in 2021, and we hold the 19th ICG annual meeting in 2025. Okay, today I introduced the KPS and CAS status update. These are able to increase usefulness of civil GNSS users who are located in East Asia. Thank you very much.
Okay, thank you very much. So, and thanks to all of our panelists here for their introductory presentations. So now we have some time left in the session, and we will move to the question and answer part of the session. And so I guess as the chair of this panel or the session, I will take the prerogative to maybe ask a couple of questions just to get things started. And then I will open it up to others who may have questions that they've thought of as these presentations were taking place. So I will start off and just note that last year, you may recall, the GPS program celebrated its 50th anniversary. So over the last 50 years, we have seen the development of a number of GNSS, with of course more on the way. So my question for each of our panelists is, from your country's perspective, what has been the most significant impact from the development of your system or the global system of systems? And this question is kind of broad, so I would expect that there might be different answers depending on how you want to interpret this question. But I would be interested in hearing from each of our panelists. So maybe we just, for the first question, we'll just run down the line. Start with GPS program.
Yeah, thanks. So, you know, even though the GPS system was originally intended to have civil uses, and then was later, you know, put into law to set and ensure that, I don't think anybody could have envisioned the impact that has grown to over time. It has become ingrained in the critical infrastructures of many nations. It is a backbone of global economy. You can find GPS receivers in nearly every system or vehicle, and sometimes even multiple ones, because they get embedded into subsystems, and then those get put together into bigger systems. And it has basically infused our daily lives. And not just from the perspective of navigation, but also in the distribution of precise time anywhere you may be without having to be hardwired into a network or a time source. I think that's been incredible. An incredible impact.
Thank you. I think the BDS best achievement, I think, is its continuous enhancement in global coverage and the service capabilities. Since its development commenced in 2000, the BDS has undergone several development stages, including BDS1, BDS2, and the BDS3 systems. achieving a significant transition from regional to global coverage. In particularly, the BDS3 system completed in 2020 has established a stronger global service capability. It offers more precise navigation, positioning, timing, and short message communication capacity. The system delivers all weather, all time, and highly reliable service to users on land, at sea, and in the air. That's all. Thank you.
Thank you. Not for the provider side. In Japan, I believe that the user side has expanded significantly. Personal smartphone and the car navigation system can now provide local information. No one is surprised that we are using space, but we consider this DNS as the best example of space utilization.
Thank you. As I mentioned at the presentation, we are expecting KPS to provide reliable and high precision PNT information for emerging applications and natural infrastructures for the post-industrial revolution. Thank you.
Okay, thank you to our panelists here. Maybe we'll turn to our online presenters as well. We'll start with Dominic Hayes.
Yeah, thanks. So in terms of what we think the most significant impact is from the development of our system, but probably more so the development of the global system of GNSS, is really the accuracy and improved availability that's provided by having so many satellite navigation systems available, particularly in urban areas, in urban canyons, for example, where the availability of an increased number of satellites enables realistic navigation, still to a very high level of accuracy. And as Chris said, I think it's allowed GNSS to be embedded into almost everything we do these days. From our own system perspective, I think probably the most valuable contribution that we've made is the search and rescue service. We are incorporated into the Cosmos SARSAT system, and previously it would take up to 4 hours to get a position fix from an emergency beacon. That is now well under 10 minutes, and the accuracy is now improved significantly over what it used to be. So I think that has the biggest impact in terms of the number of people that have been able to be saved through the introduction of the Galileo service. Thanks.
Okay, thank you, Dominic. And now maybe GLONASS, Yvonne. We can't hear anything.
Yes,
there.
Yes,
okay.
Okay. Thank you, Jeff. So for our perspective, the strict requirements of our user toward better accuracy draw the major line of the GLONASS evolution for the more than a decade. Also, the development of the user equipment and it becomes smaller and smaller and integrated in almost all areas of our life. So the innovative application and as autonomous cars and unmanned aerial vehicles require more accuracy and they need the enhancement of the robustness and the integrity. So that's why we plan to further develop the GLONASS system and services as well. Thank you.
Okay, thank you. And how about from NAVIC, Dr. Suara?
Yes, with respect to NAVIC and the Indian regional constellations, so what I can say is that has made us to an independent PNT service we are able to provide, which indicates the complete design and development and maintenance of complete PNT service across the Indian region. We acquired that technologies and capabilities. And also it definitely indicates that there are a lot of other technology developments also happened, including in the navigation segment, the navigation payloads, atomic clocks, and other GNSS receivers, and the ground segment infrastructures. These are a lot of technological advancements and developments and investments also happened. This is one part of the system development. And when it comes to the applications point of view, we have got various applications which is having huge impacts in the livelihood of common man, as well as for the usage of critical infrastructures in the country, the transport sector, etc. We have a lot of advancements through this implementation of the navigation systems. Also, as I said in my presentation, the services what we are offering through the short messaging services for the fishermen, this is well appreciated across all parts of the country. These are the few updates on, impacts what we have GNSS systems created in the country as far as we are concerned. Thank you.
Okay, thank you very much for very interesting responses. So we'll do one. I'll take one more question here, and then we can see if there's anybody in the audience who has any questions. So the last question was kind of looking back on the programs and the history. The next question is going the other direction, looking ahead. What do you think will be the most important improvement to your system in the next few years? And maybe for this one, we'll go in the reverse order, just to mix things up. We can start with our online participants first. And back to you, Dr. Sura.
Okay, next few years, what we are thinking, we are thinking of expanding our coverage area. Right now we have the regional coverage, so we thought of we are having real requirements of increasing the coverage area. That is one part. Second part is the anti-spoofing technologies to be implemented on board itself, like NMA systems, NAVIC message authentication systems we wanted to implement. And also when it comes to the value-added services and the PPP and high accuracy services, which can offer centimeter level accuracies, we are looking for such kind of systems. And the second generation NAVIC spacecraft, whatever we are, first launches happened in NVS-01. So in the coming 2 years, we will be completing that constellation with the second generation spacecrafts also. This is what our plans for the next few years. Thank you.
Okay, thank you very much. And how about for GLONASS, Ivan?
Yes, thank you very much, Jeff. So, as it was mentioned in my presentation, the development.
Could you speak up a little bit? It's
Yes.
really hard to hear you.
Can you hear me now? There's probably some issue.
Okay.
Can you hear me now? Yep.
Yeah, a little better. Yep.
Okay, thank you very much. Okay, so as it was mentioned, the development of a new generation satellites in high orbit complex will be the most significant contribution to the development of our system and its services, and also implementing the anti-spoofing technologies and the development of a new code signals for the GLONASS. Thank you.
Okay, thanks. And how about for Galileo, Dominic?
Yeah, for our system, I think authentication is a key feature. I mentioned the OS NMA that we're soon to launch, but we also have a more robust commercial authentication service that will be launched in the next couple of years, which will give an even more confidence to users that the signals they're receiving are genuine satellite navigation signals and not from a spoofer. And we've also introduced the high accuracy service, as I mentioned. But I see that high accuracy is becoming a focus not just for our system, but for many of the other systems out there. And I think the increased accuracy will open up a whole new range of applications, in addition to those new applications that are coming from the authentication features, which will give confidence to applications that maybe can't be considered at the moment because of the risk of spoofing. So I think there's a whole new range of possible uses from these new services. The other one I wanted to highlight is the use of E5. Currently we have E1 and E5 used as signals for dual frequency, but actually E5 itself is a very wideband signal that could offer some very interesting features with a single frequency front end. And so having E5, and particularly with a pilot to provide increased or decreased time to first fix, could also open up a whole new range of applications.
Very interesting. Thank you, Dominic. Okay, over to KPS.
Okay. Actually, as you know, the KPS program and R&D has been in progress in 2022. We are in the stage of designing of our system. So in the next few years, the preliminary design and then critical design of our system and international cooperation will be progressed. And for the signal and constellation design are also ongoing. 2 years ago, we are also submitted the application for international satellite network to the ITU, and from this year, we are started the coordination with the related countries. Thank you.
Okay, thanks. Now QZSS.
Thank you so much. As I presented for Japan for this decade, we have to make struggle to establish 7 satellites operation soon, and also to develop the future 11 satellite constellation design with high accuracy. In addition to that, these days we can hear much number of security threats to GNSS, such as spoofing and jamming in various fields, especially drones, flying vehicle, and land logistics. We recognized security and anti-tampering properties are becoming more important. Thank you.
Okay, thank you. And BDS.
Okay, I think the most important aspect of BDS is the improvement of service performance. We have improved the system functions and the service performance by optimizing the operation of in-orbit satellites, recon graduation of satellite in software in orbit, and the real-time monitoring of facility on the ground. Last year, we launched the first BDS-3 backup GEO satellite and 2 new MEO satellites I mentioned in the slides. They are of great significance to improve the reliability and the service performance of the BDS. For example, the improvement of short message communication capacity and the global integrated detection of navigation signals. They will support the stable operation and large-scale applications. With ongoing technological advancement, we believe that BDS will continue to bring us more surprises in the future. Thank you.
Okay, thank you. And finally, GPS.
Yeah, thanks. I mean, in the next few years here, probably the biggest improvement to our system will be the installation of the new ground control segment, along with the finalizing of the new civil signals. As Dominic mentioned, we're also very excited for the L5 band. The width of that band offers, close to a 10 times improvement in processing gain in the receiver. and those civil signals we view as being very important for safety of life applications and users worldwide. Thanks.
All right. Thank you. So we don't have a lot of time left. So I want to make sure that we get to all of you in the audience who might have some questions. So maybe we open it up to anybody who might have a question, either for a specific question for a provider or for the whole panel. Does anybody have any questions they'd like to ask? Okay, I don't see any hands raised here. Is there anybody online who has a question? Okay, well, I guess in that case, I will ask another question since we do have a few more minutes. Over the past 20 years or so, we've seen GNSS expand to include combined MEO and GEO or IGSO satellites. And so I guess my question is, do you anticipate your system expanding to include the use of LEO or low Earth orbit satellites? Or do you think the LEO systems will stay independent of the current MEO and GEO systems? So I guess we'll go back through, start with GPS.
Yeah, thanks. I don't think I see GPS itself expanding into LEO. I view the LEO expansion more as a commercial endeavor undertaken by commercial entities, and we expect to leverage those services to work in conjunction with middle Earth orbit satellites or perhaps even geosynchronous satellites, and work to make compatibility and cooperability more seamless between other operators and ourselves in GPS.
Okay. I think in the future plans of BDS, the integration of multi-orbit constellation is a direction and consideration. Public information indicates that combining satellites from both higher and lower orbits can better meet the diverse needs of different users and application scenarios, enhancing the system's coverage and availability. However, this also requires addressing the challenges of coordinations and signal interoperability between satellites in different orbits to ensure the overall system's stability and reliability. Therefore, a thorough evaluation of the technical reliability, compatibility, and safety is essential for the integrated use of multi-orbit constellations. Thank you.
Thank you. In my personal view, I may say it would be difficult to establish a LEO positioning system because I heard that there are some problems with the frequency and the strength of signals. However, we can, manage to that by collaborating, such as these kind of symposium. Thank you so much.
Okay. Well, I think there are some tests to solve in order to use real satellite for GNSS, such as precise time synchronization and precise orbit determination among real satellites. To solve these issues, I think real system also needs to combine with MEO and GEO systems. This multi-layer constellation will significantly enhance the current GNSS performance. Thank you.
Okay, thank you. We'll go over to Galileo. Dominic?
Yeah, thanks, Jeff. So we are looking at LEO PNT as a possible addition to the Galileo constellation. I kind of go along with what Chris said about the potential for LEO operators to be more of a commercial aspect. So they bring value, they add value to the existing GNSS offering. And people have also talked about LEO PNT kind of replacing the MEO GNSS systems, but I don't see that. The MEO orbits have a stability that the LEO orbits just don't have, and they also have the coverage. So I see long-term LEO PNT systems providing potentially added value, but not replacing the MEO GNSS systems. Thanks.
Okay, thanks. And GLONASS?
Thank you, Jeff. Generally, it's excellent question. So the short answer is it depends. So if let's the LEO complex may enable us to exploit the advantages of more high signal power and different satellite geometry. It may also strengthen our capability in the provision of point-precise position correction to our users. So what I can say that if LEO constellation will appear, the GLONASS will incorporate it. So, and the outline of the complex of this complex is still under consideration, I would say. So, yes, thank you.
Okay, thank you. And how about NAVIC, Dr. Sura?
Yeah, this is a very important question what you have posed. The world is looking forward for the LEO constellations and its prospects in the recent past. So what I feel is, from the NAVIC point of view, what I feel is the GEO and the MEO constellations are going to be the backbone and continuous the major systems. But at the same time, LEO is offering a potential area for what you can say as a multi-layered constellation with indoor communications, indoor positioning, all those things. LEO can offer definitely huge advantages, but we have to study the pros and cons with respect to the receivers and other important factors, constituent elements of the navigation. And also our NAVIC community also is studying the potential of this LEO constellation in the coming future. Thank you.
Okay, thank you. I think this is a very interesting topic, and I'm sure it will be discussed more in the not too distant future, certainly. So I think maybe we have time for one more question. We'll try to keep the answers short so that we don't run too much over our allocated time here. And the question is, what do you think GNSS will look like in 20 years? So real quick, we'll just run through.
Yeah, I think, in 20 years, we'll see a proliferation of signals from both, nation-state providers as well as commercial providers. But the real change will be in GPS and GNSS user equipment and the ability to not only leverage all of those signals, but also other signals of opportunity that may not even be specific to position, navigation, and timing, as users on the ground, seek to take advantage of all of the things around them.
As technology continuous advances and application demands grow, GNSS is focusing on enhancements in precision, reliability, and security. In terms of technology, GNSS will make continuous breakthroughs and innovations, aiming to improving improve signal quality and reduce noise interference, ensuring signal stability and reliability. In terms of applications, GNSS is expanding into a wider array of fields, including intelligent transportation, autonomous driving, and precision agriculture, driving the digital transformation and the intelligent upgrade of various industries. Furthermore, with the development of technologies such as the Internet of Things and the cloud computing, the application scenarios and the service models for GNSS are also undergoing constant innovation and expansion. In summary, we look forward to GNSS playing an increasing significant role in the advancement of human society in the future. Thank you.
Thank you. For the 20 years, smart cities and smart rural countries, for that we can establish highly accurate indoor positioning systems so that people can use them seamlessly, both indoors and outside. To realize this thing, the open-air GNSS needs to take communication with them in terms of technology and regulations. Thank you.
Okay. Well, personally, I expected that more precise and reliable PAT services in multi-layer orbit, combining 4 GNSS and 3 RNSS, including KPS, as well as LEO satellites, can be provided for GNSS ground users and space users. Thank you.
Okay, and how about Galileo?
Yeah, so I see GNSS as still being there in the future, although it will be augmented by other navigation means. But I think, I've always said this, that GNSS, it is the most accurate positioning we have available, and I think it will always be there as kind of an underlying reference. And the other systems that are used, whether they be 5G, 6G, or evolutions of G, they will always need to be referenced in some way to a global reference system, and I think GNSS serves that purpose very well. So the other thing I wanted to add is I think that we will also in the next 20 years or so overcome the indoor barrier, because at the moment GNSS is primarily used in outside environments, and inside has always been a challenge. I think we will find solutions that will enable the seamless coverage from outdoor to indoor, and that may not be satellite, but it may be other navigation means. Thanks.
Okay, thanks. How about GLONASS?
Yes, thank you. So in 20 years, the GLONASS will be a multi-layer comprehensive system broadcasting a brand new signal to immune jamming and to have immune for jamming and spoofing. And also it will provide new services on the verge of integration of both satellite navigation and communication. That's my view. Thank you.
Okay, thanks. And finally, Navik?
Yeah, it's, for the next 20 years, when we look at navigation systems, what I can say is every part of the human life is going to be governed by the GNSS systems, which predominant is going to be the artificial intelligence-based systems. They will be hugely depending upon the navigation and timing aspects. And also it will be required to have indoor navigation, as well as probably what systems may look for highest level of integrity services will be needed, especially when unmanned vehicles and other kind of systems what we use the GNSS. Also, we may have this multimodal integration also will be one of the prospects what we can look at is seamless integration with other sensor technologies like LIDAR and cameras would enable advanced positioning and environment awareness. paving the way for truly autonomous navigation in various environments. And it is going to be an integral part of human life in coming the next 20 years. Thank you.
Okay, thank you very much. Very interesting, a very good discussion, I think, here. And I think we've reached the end of our time. I don't want to get us off schedule too much, so I think we will end our panel session here. I'd like to just give all of our speakers, panelists, a big round of applause. Thank you very much. And with that, we'll conclude. So thank you, everyone.